In today's digital world, credit card transactions are happening at lightning speed. But with this convenience comes a massive risk: fraud. Detecting fraudulent transactions in real time is not just important, it's essential. In this tutorial, we'll build a machine learning model that can detect credit card fraud using real transaction data. Let's dive deep into the world where AI meets financial security. We'll be using the popular credit card fraud detection dataset from Kaggle. It contains over 280,000 transactions, of which only 492 are fraud. That's less than 0.2%. This shows how imbalanced the data is, an important factor we must address. First, we import the dataset, handle missing values, and normalize the features. Since the dataset is already anonymized with PCA transformed features, we don't need to worry about raw transaction details. However, we will scale the amount feature and separate it from the class label, where 1 means fraud and 0 means legitimate. Now, we train a random forest classifier, known for its robustness and accuracy. We'll split the data into training and test sets, train the model, and evaluate it using accuracy, precision, recall, and the confusion matrix. AUC ROC will give us a complete picture of model performance, especially under class imbalance. Precision and recall are more important than accuracy here. We want to catch frauds without too many false positives. A high recall means we're catching more frauds. A high precision means we're avoiding false alarms. We'll also visualize the confusion matrix and ROC curve. And there you have it, a full pipeline to detect credit card fraud using machine learning. In the real world, this model can help banks and financial institutions save millions. With continuous learning and real-time updates, machine learning can become the first line of defense against financial fraud. We use pandas and NumPy for data loading and numerical operations. Train_test_split to divide data into training and testing sets. Random forest classifier, the machine learning algorithm used here. Classification_report, confusion_matrix, ROC_AUC_score, ROC_curve, evaluation metrics. SMOTE balances the dataset by generating synthetic examples of the minority class, fraud. Matplotlib.pyplot for plotting graphs, ROC curve. We loads the credit card transactions dataset into a pandas data frame. Then normalizes the amount feature using z-score normalization to bring it to a standard scale. This is important because some models are sensitive to feature scaling. After that drops amount, since we already normalized it as normalized amount. Drops time, because it's not useful for detecting fraud, in this context. X feature matrix, all columns except class. Y target labels, class, 1 for fraud, 0 for non-fraud. Next, SMOTE generates synthetic samples of the minority class, fraud. This avoids the model being biased toward the majority class, non-fraud. Then we splits the balanced dataset into 80% training and 20% testing data. Random_state equals 42 ensures reproducibility. After that, initializes a random forest with 100 trees. Trains the model on the training set. Next, we uses the trained model to predict the classes of the test set. After that, classification_report shows precision, recall, F1 score for both classes. Confusion_matrix breaks down predictions into TP, TN, FP, FN. ROC_AUC_score indicates the model's ability to distinguish between classes. Finally, predict_proba, X_test, gets the probability of class 1, fraud. ROC_curve computes false positive rate, FPR, and true positive rate, TPR. PLT.plot visualizes the ROC curve to evaluate classification performance.